welcome to your first episode uh, in a series of episodes where I'm going to be showing you how to forecast severe weather from the basics all the way to the more complicated stuff. So let's get into it. Um, the primary thing, you might hear about these on the TV sometimes. So when you're watching TV, for example, the Weather Channel, um, they forecast the weather, at least you think. Truth is, they are showing the forecast that has been made by actual meteorologists behind the scenes who look at these weather models. So these weather models are the raw data um, that the computers create based off current conditions and going forward, if that makes sense. So it's the most raw data, most accurate, and some might say, well, if we have the computers generating all the stuff, why would we need people anymore to forecast it? And the reason is because there is still a high level of interpretation of different conditions that needs to be done to then forecast threat levels, whether it's severe weather, winter storms, etc. You still need that human interpretation. So that's what we're going to be learning throughout this series. Now, as we start with models here, one of my favorite websites to go to is pivotalweather.com. That link will be in the description. Um, so one of the first things you need to know when you get into this is there are actually many different models. Now, don't let this overwhelm you. There's really just a few basic ones we need to know. Um, I'm going to start with the very, very basic ones, and then I might make a video later on about some of the others. Um, but for now, yeah, we're just going to start with some basic ones. So the first one, we're obviously on it here, and yeah, on Pivotal Weather, if you want to choose a model, so up here you got your model. You can click here. It's got all these lists of models, okay, that you can choose from. You can also choose your zoom. So right now we're nationally zoomed out. You can go regional. Click this, and you can go to little sectors across the U.S. Anyway, so we don't need to get into that. We just need to look at this one right now. So we're on the GFS. The GFS is, so with models, they have different lengths that they go out. And generally speaking, the farther they go out, the less what we call high resolution they are. So for example, when we're looking at the GFS like this, right, and it's showing projected snowfall totals, okay? So let's say we go zoom in here real quick, and we zoom in over where there's a lot of snow forecasted, and you can see it's not the most high resolution image, right? So you have these kind of big, almost pixel-like areas. There's not much detail, right? So basically, the farther you go out, or the longer the models go out, generally the lower resolution they are. But you can also get a longer range of what you're looking for. To contrast that to, if we look at the most high resolution one, but also doesn't go out that far, you can just see from looking here, very detailed, very smaller pixels, I guess is a good way to put it and think about it. So anyways, back to the GFS. GFS goes out to 384 hours out into the future, so it goes very far. Now, generally speaking, once you get past, really about 144 hours or farther, it's really, there's almost no point in looking at it except for general trends in weather. You're not really going to get any details on particular weather systems or anything like that that are accurate, usually. Now, there's ways to determine how accurate it is, but generally speaking, yeah, you don't really want to go much farther than this. So, that's your GFS, and we're gonna get into like the different. We're gonna get into some other stuff in a minute, but first we're just gonna look over the main models so you know what you're looking at. So you're gonna use this when, excuse me, when you're looking at potential severe weather system. that it's multiple days out, maybe 5 days out, something like that. So where the other models can't reach it, this one will be able to. But you're also not going to get nearly as much accuracy. Now the next one down, we're going down from longest range to shortest. So the next one down is the NAM, or the North American model. This one's just a bit more high resolution. Actually, it's quite a bit more high resolution, and it only goes out to 84 hours, as you can see here. So this is when you start getting more. GFS really is a very, very pixelated. There's not much detail to it at all. As you're getting into the North American model, there's a lot more detail, but the very local county-like details and stuff like that are still not there. But you're getting into the point where you can get an idea of where generally the system's going to set up, and it goes out to 84 hours. The next one is the 3 kilometer NAM, and the reason it's called that is because, excuse me, sorry, you can see it's a lot finer, higher resolution here. So there's only 3 kilometers. The pixels are 3 kilometers by 3 kilometers, basically. I guess is how you can think about that. So that's that. It goes up to 60 hours. Yeah, I'm extremely sick too, so that's why my voice is so screwed up. But it goes up to 60 hours. And then finally, the last one to look at, one of my favorites, is the high resolution rapid refresh, or HRRR. So this one is extremely, extremely high resolution. Tends to be very, very, very accurate. A lot of times, once you see features in this, it's pretty much going to happen. But it does depend event to event. So, interesting thing with this is now is a good time to introduce you guys to how it does the timing. You might see up here or here it says 12Z or 00Z. All that is that's a different timing method. Now, I'm not going to go through teaching you all that. It's pretty simple once you get the hang of it. You just got to get used to it. I'm going to put this link in the description, which has all the conversions. It's called Zulu time. And so, yeah. Now, up here, you might as well do this now. Where it says run, that's basically when this specific group of forecast hours was created by the computer. So here it says 12Z, which is actually equivalent to about 8 a.m. So this forecast group was created about 8 a.m. today. Now, how do you tell? See, this is where you select what hour you want to look at. How do you tell which one you're looking at right now? Simple. You look up here, it says forecast hour 36, so that's just how many hours out you are going. This is valid. When it says valid, that just means that this is the hour it's showing. So Saturday, 2019, March 2nd at 00Z. So that's what this is showing right here. Okay? So, back to the high resolution model here. One of the new features it has is every 6 hours, so 12Z, 18Z, and so on, 0Z, it's going to go out 36 hours. Now the rest of the time, this one updates every hour too, by the way. The rest of the time, it's going to go out to 18. So, pretty short range, also extremely accurate, extremely useful. Now, we've gone over the models, the basics of the models at least. So you can go ahead and ask any questions down in the comments. Maybe I can add some of the questions that I missed because there is a lot to it. Add that in the next video. But now that we've done this, we can actually look at the basics a little bit. So the first thing that we're going to want to know is kind of how these pressure systems work and what they have to do with severe weather. So right now we're going to go to MSLP 10. Don't worry about all this, but basically what this is, when it says MSLP, it's just your surface pressure map, okay? So high pressures, low pressures, you probably hear about them a lot in the weather. So if we go in here, see, you got a low pressure out here, low pressure, high pressure. If you want to know these numbers up above, one of these are too. That is the lowest, or in the case of a high, highest pressure um, within that pressure system. So in millibars. So lowest pressure in this low pressure would be 1,003 millibars. Highest pressure in this high pressure right here would be 1,024. Right. So um, now let's see here. I'm just gonna put it into a loop real quick. Don't worry about this. I'm gonna put it in a loop and see if we can find a good low pressure system, stronger one to kind of uh, explain this here. So, working on it. Here, I'm gonna come back right back in a second here after I find a good. I just want to find a good low pressure to make an example of. So, 1 second. All right, so I haven't found the best example ever, but I can still teach you off it here. So, um, oftentimes when you look into the weather map, say it's on the Weather Channel or something like that, it might look something like this, right? So ignore all this stuff over here, all this, ignore that, right? So you got your low pressure, and you'll notice this is a common theme. You got your low pressure, and then you have a cold front coming down like this, and then a warm front. And this is generally one of the biggest ways systems produce severe storms. Now, the question becomes, why is it always set up like this? And it's actually pretty cool, pretty simple. So, one of the main things, and if you're actually really committed to knowing this, you might be able to memorize this. If not, write this down. One of the big things you need to know: um, low pressure. The winds around the low pressure circulate counterclockwise, whereas the high pressure winds circulate clockwise. So, here, if you know how to read wind bars, I'll just do the basics right now. You see these black lines, not the isobars, not these, but circle one. Just make sure you guys can tell what I'm talking about. One of these. So that right there is a wind bar, and the side with no curved end, the open side, is that's pointing towards the direction the wind is going. So you can see around this low pressure, they are all going in this direction, just like that. It's terrible arrow. Yeah, make this a bit bigger too, so we can see. Yeah, that's better. All right. So they're all going like that. So what's this mean? Well, generally, here we can do this over here. Cold air, cold air tends to be up in the Canadian area, kind of basic, right? So cold air is technically more towards the North Pole, and we've got some red right here, and warm air is okay. Warm air, we can get the red. I don't know what the deal with this is. Red. Alright, so warm air is generally south. Okay? Pretty straightforward. You know this. Tends to be basic common sense, at least in the northern hemisphere. So, what happens is here, as these winds um, start consistently right here pulling from the south because of the counterclockwise movement, right? Pull from the south, pull from the south, pull from the south. So, what happens is you start to create kind of a warm bubble of air out here. Meanwhile, here you can see there's a turning of the wind. So back here, all this stuff, and here, I'll illustrate this again, make it a bit easier. All this stuff is diving in from. All right, and my mic just died, so sorry for that quick pause. So what we got is it's pulling the cold air down here, And then as it comes back around, obviously, it's going to, instead of pulling stuff from the north, it's going to start pulling stuff from the south. Pretty straightforward. So this warm air is going to keep coming up. So you can see the wind barbs, and see right about here, it starts pulling back towards the south till it ends up pulling back around, obviously. So what we can do with this is we can actually, without looking at the temperatures, I can show you roughly where the cold front and the warm front would be. So all this air back here is starting here. All of it's pulling from the north. So it's going to be probably right about here. And this is all just based off the wind barbs that the low pressure is creating because it goes counterclockwise. So you can see it goes back here. Something like this. Right? So there's your cold front, kind of rough. And then warm front. How far does this warm air come up? So you can see wind barbs still pulling it all up. Real quick, so you can draw a warm front. Shift it over here. So you got wind barbs pulling all this air up, still pulling it up, pulling it up, pulling it up, pulling it up. And really, like, it's going to be right about here because it stops pulling all this warm air up. Right about here. So it's pulling it all up. There you go. You got your rough warm front, rough cold front. And if you can't see it yet, again, here's why it works, right? You got your cold air coming back here, keeps coming around until the wind's to the point where it's starting to pull warm air up. This is where it clashes. You got your cold front. And it's pulling it up here, and it keeps going. Honestly, the warm front might be farther up because as much as it's going to start being less warm because it's pulling more from the east, it is still coming up and around like this. So really, the warm front probably ends more up here, but the more sudden change is going to be right here. So in this area, you got what's called your warm sector. That's because all the warm air is pulling up. And back here, you got your cold sector. Here's the dividing line where the cold front is coming, and the dividing front line where the warm front is. So let's test this real quick, see how accurate we were with the temperatures. Sometimes it's less obvious, but let's see how accurate we were real quick. Let's grab the temperature, and then let's put the lines back up, and look at that. You can see kind of the cold air back here. It's pretty rough, you can tell, and there's probably more factors going into it than just what I showed. But you can see all this warm air that I was talking about surging up here till it roughly stops around here when it starts pulling it back around. The same thing back here. I mean, low pressure is back here. Sometimes when low pressures are even stronger, actually, sometimes you'll see the warm air come up like this, and you can actually just by looking at the temperature, you can see it come back around and curl back around. It's pretty cool. So that's generally why you get that consistent pattern. Out here is where the warm front, or out here is the warm sector where your storms are going to form, generally speaking. And so that's kind of what you need to know. That'll give you a basic idea of the physics going into a severe weather threat. It'll give you a good preface for the upcoming videos that I'm going to do here. And you're probably wondering about high pressure too. We're not going to go into that too much right now, but basically what you need to know is, generally speaking, when there's high pressure, there's not going to be too much weather happening. Not much is usually triggered by it. So That's gonna be this video. Next video, we're gonna go into even more stuff. It's gonna get more fun as we go down the road. This is very basic stuff to start out with. And again, if you have any questions, just comment them below, and I can add those answers into the next few videos. Thanks for watching. Have a good day.